All right, guys, section 1.1, pre-calculus. This one's all about modeling and equation solving. Going to serve as a little bit of a review for some of the algebra, solving equations. But also we will talk about using a graphing method. Sometimes if equations are a little bit kind of messy to do and algebraically, you don't really want to mess with them. We'll talk about how to use your either Desmos or another graphing app, even a graphing calculator to solve things. But first off, let's just start with a real simple example. So obviously you see something like this in algebraically. You guys, everyone has solved things like this. We want to just get the variable by itself, right? So of course we can solve this. Now I just want to talk about the other method. If you wanted to use a graphical method, okay, and let's say you wanted to graph the both sides of the equation separately, right? So what you could do, you could graph 3x plus 2, graph that as y1, and then in y2, or if you're using Desmos or some other version, some other software, you could graph 10. And just kind of look for their intersection, right? So I don't have the tools. I'm not able to show my screen right now with that, but I think we should be able to do this without. But basically what would end up happening, we would have the 3x plus 2, of course, has a y-intercept of 2 and a slope of 3. Okay, so 3x plus 2, of course, is something along those lines. And then 10, of course, is going to be just y equals 10 is a horizontal line like that. And what we would find is that where they intersect, right, the x value there would be 8/3, like 2 and 2/3. So it'd be somewhere between 2 and 3 on the line here, right down there. Okay, so just keep in mind you have options of using graphs or even tables. Sometimes tables are a little more difficult because the answer to this one happened to be a fraction. So what I mean by that is if you put 3x plus 2 into your y equals on the calculator and pulled the table up, you might not ever see where it actually equaled 10 because your table's defaulting to show only whole numbers for x, and our answer clearly was not a whole number. So just using different representations, though, is kind of what this is all about. Let's look at another example. Okay, so here's another example of an equation. This one, what type of function is that? Okay, so that's an absolute value function, right? So the way absolute value works, remember, is that the absolute value is measuring a distance, so it cannot be negative. So what we do once, if we have the absolute value function, the expression is already by itself, we know that 2x plus 1, okay, could equal 5, right? Because then when we take the absolute value of it, it will equal 5. Or 2x plus 1, if it equaled negative 5, right, since it's in absolute value bars, when you take the absolute value, it would also end up equaling 5. So we're going to set 2x plus 1 equal to 5 and equal to negative 5. And we're just going to solve them both, okay, using algebra here. So we'll subtract the 1 from both sides and divide by 2. Okay, same thing over here. Subtract 1, negative 5 minus 1 is negative 6. And we would divide by 2 to get negative 3. Okay, now this is one where you might be able to use the table on your calculator, right? And you're not going to know ahead of time, that's the thing. But this one, since we got nice whole number answers, what I mean by using the table is if we were to put in your y equals and we put in absolute value of 2x plus 1 and go to the table feature, okay, you would find when x equals 2, the y value would be 5. And when x equals negative 3, the y value would be 5. So that one you would actually be able to see in the table as a way to do that. Okay, again, most people are probably going to solve that just algebraically the way we kind of did first. The other option, again, is graphing. Okay, if you think about the graph of these, and you may need a calculator to help graph and whatnot, but we'll get more into the details later. But this section is just kind of about, the different methods and stuff. So just showing that real briefly. So the graph, the 2x plus 1, since it's an absolute value function, it's actually going to do something like that. I just threw it in my calculator because I was trying to do it quickly. But it was shifted to the left and vertically stretched and all that stuff that we're going to talk about actually in the next section. And then, of course, y equals 5, which was the other side of the equation, looked like this, just a horizontal line again. And you can see the two the two solutions. One occurs when x equals 2, and the other occurred when x equaled -3. Okay, so again, for those, I wouldn't really too much about the graphs in tables. Just know that there are other options out there in case you do get an equation that's kind of difficult to solve algebraically. You always have the graphing option. Okay, and the cool thing is if you use Desmos, which is an app you hopefully saw in Algebra 2, if you just graph the absolute value of 2x plus 1 and then graph y equals 5, it'll kind of give you points where you can just select them and it will give you the coordinates, and you just pick the x value of those intersections, right there and right there. Okay, another example here. This one is the square root of 3x equals 2x minus 4. Okay, so what type of function is that? Okay, that's a radical function, right? Fancy name for a square root function. And if you want to solve that, if you have an x under the square root, we need to square both sides, right? So we're going to square both sides. Okay, so squaring something under a square root will, of course, just make the square root go away. Now on this side, we got to be careful. It is 2x minus 4. I'm going to write it this way, times itself. Okay, it's not going to just be squaring the 2x and squaring the 4. It actually needs to be FOILed out. Okay, so or distributed. So when we do the FOIL, 2x times 2x is 4x squared. Right? So I'm just kind of distributing everything out. I did 2x times 2x. Now I'm going to do 2x times minus 4, which is minus 8x. And then minus 4 times 2x is another minus 8x. And then the minus 4 times the minus 4 is a plus 16. Okay, so let's see what we got here. 3x equals, we have a 4x squared. Combine those middle terms, minus 16x and then plus 16. All right, now what do we have? Besides a mess. We have a messy equation here, right? So we need to get it equal to 0. This is our old friend. This is a quadratic, right? We got the 4x squared in there. So if we subtract 3x, we will get something in standard quadratic form, which will allow us to use the quadratic formula, right? Okay, so I mean, we have factoring, we have some other options, things we can try, but in this case, I don't know, it looks kind of messy to me, right? So I'm thinking probably quadratic formula, so let's pull that out. So we know x equals opposite of the b value, plus or minus, right? Square root and all this stuff. B squared minus 4 times a times c. Okay, we are expecting you to remember all this stuff. All over 2a. Okay, I expect you to remember it, but I'm reviewing it. Okay, it's not something that you probably used over the summer much, but hopefully seeing it comes back to you now. So if we start calculating, again, my advice, I'm going to start doing the negative 19 squared minus 4 times 16. I'm just going to turn that into one single number. Under the square root there, oops, let me get that a little neater. Under the square root, we have a 105. Okay, that value is called the discriminant, 105. Okay, all over 8. And that, written this way, this is an exact value, okay? If we wanted to, if we want to get just decimal approximates, you gotta whip out your calculator and let's do 19 plus the square root of 105. And then press equals, then divide by 8, right? So 19 plus the square root of 105 is 29 point something. When I divide by 8, I'm getting around 3.66. Okay, so there's one approximate answer. And then finally, when I do 19 minus the square root of 105 all over 8, I am getting, divide by 8, around 1.09. Okay, so there's our answers. That was solving algebraically. Okay, if we were doing that one graphically again, just to kind of get a rough sketch of what it looks like. So remember your square root functions actually look like something like, let's see if we can draw one on here. Something like that. That's roughly a square root function. And then of course the 2x minus 4 is a nice linear function with a slope and a y-intercept. So something like this. Okay, and what ended up happening? Okay, looking at my calculator screen or Desmos, I'm only seeing one intersection. Okay, that's kind of an advantage to doing the graphing method, right? We got two answers here. Okay, let's check them and see, what is going on. Okay, so let's go to the original. Just by a quick look at my calculator, it looks like the 3.66 is the one that's right. Okay, so normally if you didn't have the graph, you'd have to check them both. But this one kind of appears to be right. Let's see what happens with 1.09. Why does that not work? So let's just check the x equals 1.09, right? And see if we can notice anything that's going on. So checking that one into the original, right? It was the square root. Oops, there's my pen here. 3 times approximately 1.09. Does that equal 2 times 1.09 minus 4? Right, so I'm just checking these out, right? So I'm just getting in a handy calculator here. The square root of 3 times 1.09. That is about 1.808 approximately. And the other side of the equation here, 2 times 1.09 minus 4 is negative 1.82. Okay, does that seem reasonable? Is that right? And no, that is not right, okay? I can tell right away, actually, that if this side's a negative number, and this side was the square root of something, right? The square root of something is not going to be negative. So that tells me this 1.09, if you remember what we call that, extraneous, right? Okay, that happens with a lot of these square root functions. When you square both sides like we did in this very first step here, it introduces the possibility of an extraneous solution. Okay, so using the graph, we can kind of see this one was about the 3.66. At 1.09, there was not another intersection of these graphs. So just kind of use both methods, okay? You can use these to kind of check each other out, but you always want to check your solutions, and a graph is a good way to do that. Okay, so hopefully that helps. Just open your mind up to having other options to solving equations, as far as not only just using algebra, but you can also use graphs and tables.